Hello, grade 7. How are you? I hope everything is well with you. This is me, teacher Yomna Tore, and today we are going to revise science together. Let's start. As you know, we have 3 units. Let's begin with Unit 1, the chemical reaction. Lesson 1, chemical combination. So, first, let's talk about elements. As you know, we have a lot of elements on Earth. And every group of elements are held together according to their properties. So we have metals, we have nonmetals, and we have noble or inner gases. What are the differences between them? Let's first talk about metals. Metals, they are elements which contains 1, 2, or 3 electrons in the outermost energy level. Like what? Like for example, sodium. Let's remember together how can we make the electronic configuration. So for example, what is the symbol of sodium? Do you remember? Yes, it's Na11. Okay, so how can we distribute the electrons? First, we write the nucleus, we draw it, and then the first energy level is filled with 2 electrons. The second one with 8 electrons, 2 plus 8 equals 10. 11 minus 10 is 1, so the outermost energy level contains just 1 electron. So this is metal, super. What about magnesium? Magnesium contains here 12 electrons. So when we are distributing magnesium, so here we have 2, here we have 8, 2 plus 8 is 10, 12 minus 10 is 2. So magnesium contains 2 electrons in the outermost energy level. Super, so magnesium is metal. Okay, what about nonmetals? Nonmetals, they are elements which contains 5, 6, or 7 electrons in the outermost energy level. So, like what? Like, for example, nitrogen and oxygen. Let's try to distribute the electrons here. So, nitrogen, it's N7. So, here we have 2, and here we have 5. So, it's 5 electrons. So, this is non-metal. Super. What about oxygen? Oxygen, it's O16. So, here we have 2, and then we have 8, and finally, we have here 6 electrons. So, 2 plus 8 plus 6, these are 16 electrons. So we have here 6 electrons in the outermost energy level. So oxygen is metal or non-metal? It's super, non-metal. Okay, what about noble or inner gases? These are elements which are completely filled with electrons in the outermost energy level. So, like what? Like for example, argon, like for example, neon. So, noble gases, they are completely filled with electrons in the outermost energy level, except helium. So we have here helium, we have here neon. What is the meaning of completely filled with electrons? This means that the outermost energy level contains 8 electrons. So, how many elements do we have in the Earth? There are 118 elements up till now. So, till now, the scientists discovered 118 elements on the Earth. Now, let's compare between metals and non-metals. First, metals, they are solids. All the metals are solids except mercury. So, mercury is the only liquid metal. Okay, what about non-metals? Non-metals are solids or gases, except bromine, which is liquid. So the only liquid non-metal is bromine, while the only liquid metal is mercury. Super. Okay, now let's talk about metallic luster. Metals have metallic luster. What is the meaning of metallic luster? Metallic luster means like when when you see something and you feel like, oh, it's shining. Oh, what is this? This is called metallic luster. So metallic luster happens when we have something like shining. So this is metallic luster. Okay, what about non-metals? No, non-metals are not shining. Non-metals don't have metallic luster. Metals are malleable. What is the meaning of malleable? Like you can make shapes with them. You can use them to make puts, to make cans, and so on. What about non-metals? No, non-metals, they are not malleable. Do you know something? For example, can you make shapes with the sulfur? No. So it's not malleable. Okay, metals are good conductors for heat and electricity. So, good conductors of heat and electricity. You can conduct heat and electricity by metals. What about non-metals? No, non-metals, they are bad conductors of heat and electricity. Except what? Except graphite. Do you know graphite? If you tried this before, if you open the battery, you can see inside it, you can see a graphite. It's like a rod. So graphite, it's a good conductor of electricity, but it's non-metal. So graphite is the only non-metal that can conduct electricity and heat. Okay, as we said, metals contains less than 4 electrons in the outermost energy level, while non-metals, they are containing more than 4 electrons, 5, 6, or 7. What about 8? Do you remember? 8 means that this one is inert or inactive gas. Okay, in metals, the atom tend to lose the electrons in the outermost energy level, one or more electrons. What is the meaning of this? Let's do it together. For example, if I have here Na11, okay? Let's make the electronic distribution. It's a 2, 8, 1. So is it easy for the sodium atom to lose this one electron or to gain another 7 electrons? For sure, to lose one electron. So the sodium atom tends to lose the electron and be here when it loses its positive ion. So here 2, here 8, and now it's positive ion. Positive. We can just make a plus. Okay, what about the magnesium? Magnesium, it's a 12. So it's 2, 8, 2. So it's going to lose 2 electrons. So it's like what? It's like 2, 8, and here positive 2 because it loses 2 electrons. So when it loses, it's positive. When it loses electrons, it's positive. So metals form positive ions. Okay, what about nonmetals? Nonmetals is the opposite. Nonmetals tend to gain electrons. Like what? Like for example, chlorine 17. Let's distribute the electrons here. 2, 8, and 7. So 2, 8, and 7. So is it easy for the chlorine atom to lose 7 electrons or to just gain 1 electron? To gain 1 electron, super. So when it gains, it's negative ion. So now it's 2, 8, and here also it's 8, and this is negative ion, negative 1. So nonmetals tend to form negative ions, while metals tend to gain electrons or, to lose electrons or to form positive ions. Now let's talk about the chemical bond. What is chemical bond? Chemical bond is when atoms combine together to form molecule. So through bonds, what are bonds? We have different kinds of bonds. We have ionic bond and we have covalent bond. Let's start with ionic bond. What is ionic bond? Do you remember when we said that metals tend to form positive ion and lose electron? Okay, this electron that's lost from the metal, where it's going to go where? To a place. It's not going to fly in the space. Okay, and what about the negative ion? It will gain electron. From where it will gain this electron? Oh my God. The electron lost by the metal gained by the non-metal. Let's see how this happened. So ionic bond happen when the positive ion and negative ion attracted together. When the positive ion formed and the negative ion formed and they are attracted together, this is called ionic bond. Like for example, the sodium. We said that the sodium is going to lose electron. This electron is going to be gained by the chlorine. So the chlorine atom gained the electron from the sodium that's lost by the sodium. Now let's talk about the formation of sodium chloride as an example. So we have here the sodium, which is Na11, and here it's 2, 8, 1. 2, 8, 1. So it's going to lose this electron and form positive ion. So it's 2, 8, and this is positive ion. Okay, so there is electron here that's lost by the sodium. What about chlorine? It's a Cl17. So 2, 8, 7. So it will gain electron. So now it's 2, 8, 8, and here it's negative ion. So it will, from where it will gain this electron? From this one that's lost by the sodium. So this one is going to be here. So the electron lost by the sodium is going to be gained by the chlorine. And when we have positive ion and negative ion, they are going to be attracted together, attracted in a very strong way together to form ionic bond. This is how ionic bond is formed. Let's take another example. The formation of magnesium oxide. So how magnesium oxide happen? As you know, magnesium, it's Mg12. So here we have 2, 8, and here 2. So it will lose these 2 electrons. So now it's 2, 8. And this is here, positive 2. Okay, what about oxygen? It's oxygen 16. So 2, 8, and here it's 6. So it will gain 2 electrons that's lost by the magnesium. So these 2 electrons is going to be gained by the oxygen. And here it's going to be 2, 8, 8, and this is negative ion. So the 2 electrons of magnesium is going to be lost and the oxygen is going to gain them. And then we have here positive ion, positive 2 and negative 2. So we have here ionic bond. Now let's talk about the covalent bond. Covalent bond happens by sharing electrons. It can be between 2 nonmetals. So, like for example, chlorine and chlorine, or by sharing, just by sharing, like in water molecule. We have here 2 hydrogen atoms and 1 oxygen atom, and they are sharing electrons. So covalent bond happen between the atoms of nonmetals together through sharing electrons. Like what? Like for example, the hydrogen. Here we have in hydrogen, we have 1 here. So to make H2, we need here 2 hydrogen. Here, 1 here, and 1 here. Now we have 2 electrons sharing by the both of them. Now we have something else. We have different kinds of covalent bond. First, we have single covalent bond. What is single covalent bond? Single covalent bond happen between, like when we have here, like just sharing by 1 electron. Every hydrogen atom shares with 1 electron to form covalent bond. What about double covalent bond? Double covalent bond, they are sharing by 2 electrons. Every atom with 2 electrons. So the molecule with 4 electrons. What about nitrogen? It's a triple bond. Why? Why triple covalent bond? Because nitrogen here, it's a 7. So it's 2, 5. So it's going to gain 3 electrons. This is why it's a trivalent, triple bond. Now let's talk about the valency. What is valency? What is valency? Do you remember when we were talking about sodium? When we said that sodium Na11, and here it's 2, 8, 1. And this one is lost by the sodium. This electron called valency. So the valency here is just 1. It's monovalent. Okay, what about magnesium? It's 2, 8, 2. So, yes, super, it's divalent. So, what is valency? Valency is the number of electrons gained or lost or shared by the atom. So again, what is valency? Valency is the number of electrons lost, gained, or shared by the atom. Okay, what do you think? Do you think the argon or the neon has a valency? We said that the outermost energy level contains 8. Does it will gain electrons or lose electrons? No. So it's stable. So here it doesn't have valency. Noble gases don't have any valencies. Valency here is 0. Why? Because the atom is stable. The atom doesn't need any electrons and is not going to lose any electrons. So we have here sodium. So sodium, we said it's monovalent. Chlorine, let's make chlorine. We have here 2, 8, 7. So super, it's 1, it's monovalent. Okay, let's take another example. Argon, we said it's noble gas. Okay, what about aluminium? It's 13, 2, 8, and 3. So it's a trivalent, super. So again, what is valency? Valency is the number of electrons lost, gained, or shared by the atom. Now let's talk about elements that have more than one valency. We have some elements that have more than one valence. Like what? Like, for example, phosphorus and nitrogen. Phosphorus and nitrogen are best friends. P and N. Pen, like pen. They are best friends. Look here at phosphorus, it begins with P. So both of them, they are pentavalent. Let me show it here. So it's pentavalent. And also, so this one is P and it begins here also with P. Okay, so they are pentavalent. Okay, what about trivalent? Look here at nitrogen. We have here letter T and letter I, it. So here also it's T and I. I'm just giving you a code to memorize it. So P and N are best friends. They are pentavalent and trivalent. Both of them are trivalent and pentavalent. What about sulfur? Sulfur is sulfur. It has sound S, so it's hexavalent and also tetravalent and divalent. Also, we have ferrous and ferric for iron, and ferric is trivalent and ferrous is divalent. Now let's talk about the atomic group. What are the atomic groups? Atomic group, they are like a set of symbols that put together, a set of atoms that are joined together and behave like just one atom. Like what? Like for example, like carbonate group, OH. Like, sorry, this is hydroxide, like carbonate group, CO3. Like for example, we said OH, CO3, like for example, NO3. So they are acting like just one atom. And they are containing different samples, different atoms together. Now let's remember together, lesson 2, chemical compounds. What is chemical compound? First, let's talk about chemical formula. Chemical formula, it's like a set of symbols that represent for me the number and the type of the atoms. Like for example, NaCl. So when I first see like NaCl, so NaCl, when I see NaCl, I can know that it consists of sodium and chlorine. What if I see AgCl? So I know that it's from chlorine and silver. H2O, I know that there are 2 hydrogen and 1 oxygen, and so on. So this is the chemical formula. Okay, how can we write the chemical formula? By 3 things. First, 3 steps. The first step is to write the symbols. So for example, if I want to mix sodium chloride, so now what is the symbol of sodium? It's Na. What about chloride? It's Cl. Okay, what is the second step? The second one is to write the valency. What is the valency of sodium? It's 1. What is the valency of chlorine? It's 1 also. So this is the second step. What is the third step? The final step? It's exchange. What is exchange? Exchange is to exchange them like this. So Na1, Cl1. So 1 is going to go with 1. And finally, we have NaCl. And this is how to write the chemical formula. Now let's talk about something else. Let's talk about the types of elements, the classification of elements or compounds according to their properties. First, we have acids, we have bases, and we have salts, and also we have oxides. Let's first talk about acids and bases. Let's make a comparison between them. Acids, when we put acids in water, they give us like positive hydrogen atom or positive hydrogen ion. What about base? When bases dissolve in water, they produce negative hydroxide ion. Acids began with H, like HNO3, HCl, and so on, while bases ends with OH, with the hydroxide group. Acids have a sour taste, like the lemon. Bases have a better taste. We have something called litmus paper. When we put acids on litmus paper, they change the color into red, while bases change it to blue. We can memorize it that bases begins with B and blue also begins with B. So bases change the litmus paper into blue color. Here, like HCl, as we said, like HNO3 and so on. H2SO4, bases like NaOH. Now let's talk about oxide. Oxide happens when any metal or non-metal react with oxygen, combine with oxygen. We have metal oxide and we have also non-metal oxide. Metal oxide happens when we have metal with oxygen, like sodium oxide. Non-metal oxide when we have non-metal with oxygen. Like, for example, carbon dioxide. Let's bring together the chemical formula of sodium oxide. Sodium oxide. What is the symbol of sodium? Super, it's Na. What about oxide? It's O. What is the valency of sodium? It's 1. What about oxygen? It's 2. When we make exchange, now it's Na2O. Let's try to bring for carbon dioxide. We have here C and here we have O. What is the valency of carbon? It's a tetravalent. Oxygen is divalent. When we make like this, so now it's a C2O4. If we divide, we make math here, 2 over 2 and 4 over 2. So now we have CO2. Now let's talk about salts. We have different kinds of salts. First, we have salts that we can make them by positive metal ion with negative non-metal, like sodium chloride. Sodium is positive metal, negative, and the chlorine is non-metal, negative non-metal. Or positive metal with negative atomic group, like sodium nitrate, for example. What about positive atomic group with negative non-metal, like ammonium chloride, and negative atomic group like ammonium carbonate? We have here a small note that all the negative ions form salt except oxygen. Why oxygen? Because oxygen form oxide. Super. Also, all the negative atomic groups form salt except the hydroxide group. Why? Because it forms bases. Okay, we have some salts that are soluble in water and others that are not soluble in water. They are insoluble in water. Soluble like sodium chloride, potassium sulfate, and calcium nitrate, and also sodium sulfide. How can we memorize them, teacher? Look here. Sodium chloride, this is the table salt that we eat it. Okay? Calcium, we can find calcium in milk, but can you see it? No. So actually, we can remember that calcium also soluble. Okay, so anything sodium is soluble, and calcium and also potassium. Okay, what about insoluble? Insoluble like silver chloride. Have you ever bring a piece of silver and it's soluble in water? No. So anything containing silver, it's not soluble in water. Also lead iodide. Lead, it's in the pencil. Have you ever bring a lead and put it in water and it dissolve? No. So it's insoluble. And finally, we have lead sulfate. All the carbonate groups, all the carbonate salts don't dissolve in water except sodium carbonate, potassium carbonate, and ammonium carbonate. We can remember it by making a code SPA. SPA. SPA, they are dissolving in water. carbons, sodium carbonate, potassium carbonate, and ammonium carbonate. Now let's talk about the chemical equations. But first, before starting chemical equation, let me show you an equation, which is magnesium plus oxygen gives you magnesium oxide. Look here. What is this? This is a chemical equation. What is chemical equation? Chemical equation containing like reactants, some reactants here, and then they are reacting together and gives us the product. And here, this is the condition of the reaction. This is the condition of the reaction. So let's start lesson 3, sorry. Let's start lesson 3, which is chemical equation and reaction. Okay. So chemical equations and chemical reaction. What is chemical reaction? Chemical reaction happens when you break down the bond between the reactants to form new bond with the product. So it's the breaking of the bonds between the atoms of the reactants to form new bonds with the products. Like here, like for example, when you divide this, when you break down this and this and this, and then every one from this react with here to form water molecule. So this is simply chemical reaction. Now, we have in the chemical reaction, as we said, we have reactants and we have product. Reactants, they are the elements that enter the chemical reaction, and products, which are the result of the chemical reaction. And any chemical reaction must be balanced. What is the meaning of balanced? Balanced means that the number of atoms entering the chemical reaction must be the same as the product, as the atoms, the number of atoms going out from the chemical reaction. So the number of atoms entering the chemical reaction must be the same going out from the chemical reaction. Let's take an example. For example, H2 plus O2 gives you H2O. Let's check, is it balanced or imbalanced? How many hydrogen do we have here? 2. How many oxygen? 2. How many hydrogen here? 2. How many oxygen here? Just 1. So what should we do? We have to add here another 2. Why? So now the oxygen is 2. So now how many oxygen do we have? 2. How many hydrogen? 4. Because 2 multiply 2 is 4. How many oxygen here? 2. How many hydrogen? 2. So now, okay, oxygen 2 and here 2. But here, 4 are out, but 2 entering. How? So we have here to add another 2. So 2 times 2 is 4. And here 4. So this is how we can make any equation balanced chemical equation. Now, we have different laws that like help us to use the chemical reaction and chemical equation. The first is the law of conservation of matter. Matter can't be created and can't go anywhere. Matter is conserved. How? The mass of the reactants must be the same as the mass of the product. So for example, if 80 gram entering the chemical reaction, so 80 gram must go out from the chemical reaction. This is the law of conservation of matter. What about the law of constant ratio? Law of constant ratio tells us like every element has its own ratio. Like for example here, 2H2. This means what? What is the mass number of H, or what is it's 1? So 2. 1 multiply 2, so it's 4. So 4 grams. What about oxygen? Oxygen, mass number of oxygen, or atomic number, sorry, of oxygen, it's a 16. So 2 times 16, it's 32. So 4 grams for every 32 oxygen. So if we make here simplification, so 4 over 4 is 1, 32 over 4 is 8. So for every 1 gram of hydrogen, we must put 8 grams of oxygen. This is the law of constant ratio. Now let's talk about direct chemical reaction. Direct chemical reaction. A direct chemical reaction, this is a reaction between two compounds or two elements. So for example, first, between element and element, like for example, metal and non-metal, like Na and Cl to produce NaCl. Or between non-metal and non-metal, like for example, chlorine with chlorine to produce Cl2. Or element with compound or compound with compound. All of these are examples of direct chemical reaction. Now let's talk about Unit 2, which is force and motion. Let's start with fundamental forces in nature. Fundamental forces in nature. We have different forces in nature, like gravitational force, like electromagnetic force, and finally, like nuclear force. And in nuclear force, we have two types. We have weak nuclear force that we use it in medicine, and also we have strong nuclear force that we use it in wars. So let's start with gravitational force. Who is the first one to discover the gravitational force? It's Isaac Newton. So Isaac Newton discovered the gravitational force. He proved that the force depends on the mass. What is the difference between mass and weight? Do you remember mass? We said before that mass is the amount of matter inside any object. What about weight? Weight is the mass multiply the gravitational force. So what if we want, for example, to calculate weight from this triangle? So weight is going to be mass times acceleration due to gravity. What about mass? Mass is weight over acceleration due to gravity. What about acceleration due to gravity? It's weight over mass. Now let's, what is the measuring unit here? It's Newton. So why, if I asked you, why? The weight is more than the mass all the time? Because weight is mass itself multiplying the gravitational acceleration. So what is gravitational acceleration? For example, if I have the Earth here like this, this is the center of the gravity or the center of the Earth. When I'm near to the center of the Earth, the gravity increase. When I'm going far away, so gravity decrease. This is why in some places it's 9.8 and in other places it's 10. Okay, let's look at this question. If the mass of an object at the equator equals 60 kilogram, what is its mass at the two poles? Explain. So the mass is constant. Don't forget, the mass is always constant. Mass is constant. It's never change. Now let's talk about electromagnetic force. Electromagnetic force, this happens when we have electric field and magnetic field, when we have electric force and magnetic force together. And this happened in electromagnet as an example. What is electromagnet? Electromagnet, it's here we have insulated copper and it's coiling around a part of iron nail. When we close the circuit, the iron nail works as a magnet. And we use this in electric bell and also in electric wrenches because it changed the electric energy into magnetic energy. So look here, this winch attracts the car when it has electricity. When it doesn't have electricity, it releases the car. Now let's start lesson 2. Okay, so friction force. We have friction force. What is friction force? Friction force, it's a resistance force. It's like it happens against motion. It's, you know something, do you know the brakes in the car? This is actually friction. Friction happens because when two objects are in contact together. So when we increase the friction force, the speed decreases. This is why the car stops. Let's talk about the benefits and the harms of the friction. First, the benefits. For sure, you can walk because of friction. If you don't have friction, you won't be able to move. So it prevents your feet from slipping on the roads. And also it helps in stopping and starting the car's motion. And also it helps in burning the matches. Do you know that the car tires are covered with something with a high viscous liquid, a high heavy liquid, in order to decrease the friction force? Why we want to decrease the friction force? Because sometimes it produces heat energy. You know something, when you put your finger like this in a mat and you make it like very fast, you feel like, oh, your finger hurts you. Why? Because actually this is because friction produce heat energy, and heat energy is something which is very, very bad. It causes loss of the mechanical energy, the kinetic energy, and also sometimes it causes the erosion of the mechanical of the machine's part. Okay, do you think we have forces inside the living systems, inside the biological force? Do we have biological force inside our bodies? Yes. First, we have different types of living organisms. We have unicellular living organisms and we have multicellular living organisms. What are the differences? In unicellular, like it's like amoeba, it's something very, very simple, but multicellular, like human, for example. So, what are biological force? Biological force, they are forces inside the living organism, inside the living body, that help it to continue its life. Like what? Like, for example, the heart. Do you know that the heart can take the blood from the bottom of your body, from the lower parts to the top, through pumping the blood? And also muscles. Look at the muscles, at your muscles. Muscles is something like you have here contract and relax, contraction and relaxation, which help your body organ to move and so on. Do you think this exists in the plants? Yes. How can plants have water and food? From the soil. Okay, how can this food spread all over the plant? How can this happen? This can happen by the root, because the root absorb the water from the soil. So the rising of water and salts from the soil to all the plants, this happened by a biological force, and this happened actually like against the gravity, and this take a lot of time or a lot of effort from the plant. So this is also a biological force. Now let's start to talk about lesson 3. Lesson 3, it's about motion. What is motion? Motion is the change in the position as the time passes. So when you are moving, you change your position and the time is also passing. So this is called motion. Sometimes or all the time, you are moving according to a point. Like for example, I'm going to move from like the north of the bank, or I'm going to move 3 steps from my bed, or from my place, and so on. So what is this point? This is called a reference point, and then this time we say sometimes about the motion that it's a relative speed. So what is a speed or a relative motion? What is the speed? Now, if we want to describe motion in physics or to describe motion in science, so we are going to use the term speed. Speed is a term that's used to describe the motion in a mathematical way. So speed is distance over time. What is the unit? It's meter over second, or meter per second. We have different kinds of motion. We have transitional motion and periodic motion. What is the difference between transitional motion and periodic motion? Transitional motion, like you have a starting point and an end point, like for example, the motion of the train or the motion of the car. What about periodic motion? Periodic motion, this is a repeated motion, like the wave motion, like circular motion, like the simple pendulum, the swing, and so on. So let's talk about wave motion. We have mechanical wave, and mechanical wave, they need a medium to move through it. Like what? For example, like sound. You can't hear your friend if you are talking in the space, in the moon, for example, because sound needs a medium to move through it. What about electromagnetic wave? Electromagnetic wave, it's okay, they don't need a medium to go through it, and this is why we can see the light of the sun. The light is electromagnetic wave. Okay, so give reason why we can't hear the sound of the solar explosion, but we can see the light of the sun, because light don't need a medium to go through it, but sound needs a medium to go through it. Now let's talk about an example. If you are moving in a car, you are in a moving car, and another car moves beside you in the same direction. So you will feel what here? You will imagine that the two cars stop, like there is no motion. Another example, if the car moves beside you and your car is like maybe have a high speed, so actually what are you will feel here? You will imagine that the other car moves backward. When you are with your daddy in the car, try to imagine that. This happened with me and my sister Nancy. Okay, now if you are in a stopping car and another car moves forward beside you, so actually you will feel that your car moves backward. Now let's start to talk about Unit 3, Earth and Universe. First, let's talk about the celestial bodies. What are celestial bodies? They are anybody that swim in the space, like float in the space, like stars, like comets, like asteroids, like anything. So, how can we measure the distance between Earth and other planets and other stars and so on? We can measure it using something called light year. Why light year, teacher? Because like it's a millions of kilometers. So we use light year because light year it's 9.467 times 10 power 12 kilometer. And as you know, we are in Milky Way galaxy. So the solar system is in the Milky Way galaxy, and our solar system consists of 8 planets. First, it consists of the sun, which is our star, and planets. 8 planets revolve around the sun, and we have moons. Moons are the followers of the planets. They are revolving around the planets. And we have asteroids, we have meteorites, and comets. And comets have a head and a tail, as you know. And some of them are burning before entering the earth, some of them burn before entering the earth and apart, and so on. Now let's talk about the earth. Earth has 2 radius. We have tropical radius and polar radius. Earth is like a sphere. What do you think? Which one is larger? Here, this one, this point, near to this point. So gravity here, more than this point. So acceleration here is different from this point. And the Earth completes one revolution around the sun every 365 days and also with quarter. And the distance between the sun and the Earth is 150 million kilometers. Now, why the Earth has a life inside it? What happened in the Earth? Earth contains a lot of things that help in having a life inside it. Like, for example, first, the atmosphere. The atmosphere of the Earth helps the Earth to reject all the bad rays of the sun. So it protects us from the ultraviolet rays and the infrared rays. The atmosphere has a very important role in our life. It consists of gases. We use oxygen to breathe. It's 21%. We use carbon dioxide. Plants use carbon dioxide in photosynthesis process. And also we need nitrogen to decrease the ability of oxygen to burn anything. Also, we have hydrosphere, and hydrosphere is very, very important. Hydrosphere is necessary for the living organism. We use water in everything in our life. We use water every day to take shower, to eat, to drink. Even our body contains a lot of water. The blood itself contains a lot of water. Plants need water. 50% of the living organisms live in water, in the oceans, in the seas, and so on. We have salty water and we have fresh water. What is the difference? Salty water, it's 97%, while fresh water that we needed to drink, only 3. This is why we have to keep it clean. Don't throw anything in the water, and when you are using the water, please close the tap. Okay. Also, we have here suitable temperature. We are not very near to the sun. We are not very far away from the sun. And also, we have suitable atmospheric pressure. What is the atmospheric pressure? It's the weight of the air up of your body. This is atmospheric pressure. This is why the divers, when they are going to like under the sea or the ocean, they feel like they have to wear a costume. And also the gravity. You know that some planets contains like a very big amount of gravity, and some planets you are floating, you are flying in them. So let's talk about what's inside the Earth itself. We have inside the Earth, we have crust, we have mantle, and we have outer core and inner core. It's like an egg. So let's talk about the layers. First, we have crust, which is a light outer layer, and it's from 8 to 60 kilometers. And we have mantle, which is a rocky layer. It's a layer contains a lot of rocks, and it's about 2,885 kilometers. And the third layer, which is outer core and inner core. The outer core contains molten metals, while the inner core contains solid layer. Solid layer. So it has a solid metals, and it has ferrous and nickel, and it's about 1,350 kilometers. Now let's talk about rocks and minerals. Now we studied about Earth and what is inside Earth. Let's study about different rocks. We have different rocks in the Earth. First, the scientists divided the Earth's crust into two main parts, the soil and the soil pieces. The soil, this is a thin layer cover the Earth's crust. And the solid bases, this is like containing one mineral or a group of minerals. Now let's talk about the types of rocks. First, we have igneous rocks. What is igneous rock? Igneous rock, they happen when the... Let's first talk about something. We have here in the volcano, here we have magma. I'm going to change the color. Here we have magma. And when the magma go out, this is called lava. We have two types of igneous rocks, plutonic and volcanic. When the magma cools down in a long time, so this is called plutonic. When the lava cools down in short time, so this is called volcanic. So let's talk in details about plutonic and volcanic. So plutonic, when the magma cools slowly in a long time, and the crystals here are very large. What about volcanic? When the lava cools quickly in a short time, and the crystals here are small. Plutonic like granite, and granite has a pink color or gray, and the crystals here are big. What about volcanic? It's basalt, and basalt is dark color, and the crystals here are very small, or are small. Now let's talk about the minerals that form the granite. Granite formed by quartz, mica, and feldspar. What about volcanic? Volcanic by olivine, pyroxene, and feldspar. Now let's talk about the sedimentary rocks. How sedimentary rocks happen? Let's go back to the previous slide. Let's talk about sedimentary rocks. Sedimentary rocks happen when we have rocks. This is a big rock, and this rock, because of weathering through water or through wind or through anything, divided into different pieces. So now they are different pieces. Now they are going to be transported in another place by the wind or the water, and now these small rocks are going to combine together to form just one rock. This rock called sedimentary rock. So we have here different processes to form sedimentary rocks. Let's talk about examples of sedimentary rocks. First, we have sandstone and limestone. Sandstone, it consists of sand grains, while limestone consists of calcium carbonate. The sandstone, the mineral that forms sandstone, it's quartz, while the mineral here in limestone, it's calcite. The color of the sandstone is yellow. The color of the limestone is white. So, what about the metamorphic rocks? Metamorphic rocks happen when the old igneous rock or the old sedimentary rocks has a high pressure and a high temperature. So in this time, we will have metamorphic rocks. And an example for metamorphic rocks is marble, which is white marble or colored marble contains impurities. So this was the science in a summary. I hope that you enjoyed the time with me, and I hope for you a very good luck in the exams. See you inshallah in another video. Bye.